Hello everyone, myself Sravanthi, working as Assistant Professor in Cybersecurity and Data Science in MLR Institute of Technology. Today our topic is length. So the examples on length and DFA. So the first one is design DFA for the language L which accepts all the strings over alphabet sigma equal to A comma B, where length of the string equal to 2. So our constraint is the length of the string is 2. It should not exceed 2. So the length of the string should be 2. So let us construct a language with length 2 over an alphabet A comma B. So A, I cannot keep A. Why? Because the length of the string should be 2. Here the length of the string is 1. So it is not accepted. So AB, it's accepted. AA, accepted. BA, accepted. BB, accepted. So I cannot write 3Bs, so on. Why? Because the length of the string is 2. Here the length of the string is 3 it is. So this is not accepted. So here our constraint is it should accept only the length of the string equal to 2. So what type of language it is? Finite language. It is a finite language because we have mentioned here the length is 2. So nothing but only we got 4 strings. 4 strings of length 2. So now let us construct a DFA diagram. So Q0. So what is the length I am having? String, minimum string is 2. So the number of states I can take is 3. Q0, Q1 and Q2. Q0, Q1 and Q2. These are the 3 states. So what is the first length I am having? What is the first string? AB. So on A, it is moving to Q1. On B, it is moving to Q2. So nothing but my Q2 is my final state. Q0 is my starting state. The first string is accepted. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. So the string is accepted. So the next one, what I am having? AA. AA. So Q0 on A, it is moving to Q1 and Q1 on A, it is moving to Q2. So this string is also accepted. So the next one is BA. It should start with BA. So A comma B. A comma B is nothing but either it can take A or B, not both, because A comma B. If I have a loop like this, then I can take any number of times I can call that particular A or B. So A comma B. Nothing but Q0 on B, it is moving to Q1. Q1 on A, it is moving to Q2. So this string is also accepted. So the next one is BB. So Q0 on B, it is moving to Q1. Q1 on B, it is moving to Q2. So this string is also accepted. So this is the DFA diagram. So let us check whether it is satisfying DFA or not. So what is DFA? DFA is nothing but, so the each and every state there should be 2 transitions based on the inputs. If I am having here 2 inputs, then 2 transition paths should be there from Q0 for each state. So Q0 on A, it is moving to Q1. Q0 on B, it is having some transition. Check for Q1. Q1 on A, there is some transition. Q1 on B, there is some transition. But coming to Q2, is there any transitions I am having? Nothing but any input symbols are there for Q2. There are no input symbols for Q2. So if I keep here A comma B, it won't satisfy the length of the string equal to 2. It won't satisfy length of the string equal to 2. Why? Because if I keep here A comma B, it gives me the string of AAA. It may gives me AABA also it can give. Nothing but loop means it can read any number of times. But according to the condition, I cannot keep here loop. So this is not accepted. So what we are going to do? We are going to create one dummy state or dead state or some trap state we are going to create. So and then we are going to store it here. QPy or you can take it as QD. QD. Anything you can take. So again I am having here from Q2 on A, it is moving to QD and Q2 on B, it is moving to QD. So every state, if I am having some round and some state is there, nothing but it is a state. For each and every state, there should be transitions for DFA. So even for QD or QPy, there should be a transitions on inputs A comma B. So this is the diagram. Check again whether it is satisfying my DFA. Yes, it is satisfying my DFA diagram. So this is the string for where the length of the string is equal to 2. So again, what are the tuples I am having here? Q, sigma, delta, Q0, comma, F. These are the 5 tuples I have. So what is Q? Q is nothing but set of states. What are the set of states I have here? Q0, Q1, Q2. Okay. So these are the set of states. And QPy is also set of state. What are the inputs I have? 0, A, B are the inputs. A comma B are the inputs. What is delta? Q naught. Q naught is nothing but starting state. What is the starting state? I have Q naught. So F. F is nothing but what is the final state? Q2 is the final state. Q2 is the final state. So let us construct a transition function. So delta transition function. What are the states I have? Q0, Q1, Q2 and Q pi. What are the inputs? A and B are the inputs. Q0 on A, it is moving to Q1. Q0 on B, it is moving to Q1. Q1 on A, it is moving to Q2. Q1 on B, it is moving to Q2. Q2 on A, it is moving to Q pi. Q2 on B, it is moving to Q pi. So Q pi on A, it is on self loop. Q pi on B, it is on self loop. So this is the transition function for length of the string equal to 2. So the next one, where the length of the string, design DFA for the language L which accepts all the strings over alphabet sigma equal to A comma B, where length of a string is greater than or equal to 2. It is greater than or equal to 2. Greater than or equal to 2 is nothing but what it is. We are going to have a string. We are going to have a string of length greater than or equal to 2. Greater than or equal to 2. So let us construct a language on inputs A comma B of string length greater than or equal to 2. So what it will be? Length of the string greater than or equal to 2 is nothing but I can have 2 or 3 or more. More than 2 or more. So nothing but AA, AB, BA, BB, ABB, ABA, so on. So on. So nothing but this is the string I am having, where the length of the string is greater than or equal to 2. So this is the language. So now what we need to do, check here, the string lengths are greater than or equal to 2. Greater than or equal to 2. So now we are going to construct a language. The condition is it should be greater than 2. There is no constraint that it should have some number of strings. So we can have any number of strings more than 2 or more. So what type of language it is? It is a infinite language. It is a infinite language. So let us construct a diagram. Q0 and what is again I am having is Q1, next Q2. So this is my starting state. This is my starting state and Q2 is my final state. Q2 is my final state. A. Q0 on A, it is reaching Q1. Q1 on A, it is reaching Q2. Nothing but Q2. It is reached final state. So next one, AB. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. This is also reached final state. Next BA. Q0 on B, it is moving to Q1. Q1 on B, Q2. It is reaching. The next what I am having BB. This is also accepted. This is also accepted. Next BB. Q0 on B, it is moving to Q1. Q1 on B, it is moving to Q2. So this is also the string accepted. The next what I am having ABB. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. Again what I have, one more B is there. So I can keep here B. I can keep here B. So what it happens, B is nothing but I can have one B. Yes, Q0 on A, B, Q1, Q1 on B, Q2. Q2 on B, self loop. Even it is self loop, it is reaching the final state. Why I have taken here self loop? Because the length of the string is greater than or equal to 2. Greater than or equal to 2 is nothing but I can have more than 2. So loop means 2, 3, 4, anything I can take. So this is also accept. Check here, A, B, A. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. Q2 on A, I can keep here B comma A or A comma B. Both points to same, A comma B. So it is reaching the final state. The string is accepted. So check whether it is satisfying my DFA. Whether it is satisfying my DFA, check Q0 on transitions 2, it is there. Q1 on transitions A comma B, there is some path. Q2 on transitions, there is some path. So this is the string, it is accepted. So the same way we can construct the 5 tuples which we have constructed now. So the next one is where the length of the string is less than or equal to 2. where the length of the string is less than or equal to 2. Less than or equal to 2 is nothing but I can have 2, I can have 1, I can have 0. So, not more than 2. Less than 2, 2, 1, 0, 0, 1 or 2 can be the string length. So, over an alphabet, sigma equal to a comma b. So, let us construct a language. Let us construct a language. L equal to. So, A, 1 length string, B, 1 length string, 2 length strings, AA, AB, BA, BB. Can I have 3 length strings? Will it be accepted? No, it is not accepted. Only the length of the string is less than or equal to 2. Less than or equal to 2 means I can have 0 or 1 or 2. So, that is accepted. So, this is the language. So, let us construct a DFA diagram for it. Q0, Q1, Q0, Q1, Q2. Q0, Q1, Q2. So, let me check. This is my starting state. So, when I have 0 inputs, when I have 0 length string, so what it will be? When I have 0 length string, it starts in the starting state and it will be my final state. It will be my final state if my length of the string is 0. The next length of the string is 1. Is nothing but Q0 on A, it is moving to Q1. Nothing but this is also my final state. Yes, when I have 1 length string. Next this is accepted. Next B, Q0 on A comma B. So this is the Q1. This is the string accepted. The next I am having AA. Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q2. Q2. So this is the string also accepted. Next A comma B. Q0 on A, Q1. Q1 on B, it is moving to Q2. Next BA. Q0 on B, Q1. Q1 on A, it is moving to Q2. So this is also string accepted. Let me check BB. Q0 on B, Q1. Q1 on B, it is moving to Q2. So this string is also accepted. So check whether it is satisfying DFA or not. Now what are the strings are there over a language? All the strings are accepted. But let me check whether it is satisfying DFA or not. So what is the DFA? For every state there should be transition paths over alphabet. So AB are the alphabets. So Q0, there are 2 transitions are there. For Q1, 2 transitions A comma B are there. Let me check for Q2. There is no transition for Q2. But here I cannot keep here a self loop and I cannot keep A comma B. Why? Because it is the length of the string is less than or equal to 2. But if I keep here, what the strings it reads is A, B, A is also the string it can read. This is the length of the string is 3. But our condition is it should accept only less than or equal to 2 length strings only. So this is not accepted here. So this is not accepted here. So that's why what we are having, we are going to use one dummy state, Q pi. So what are the inputs? A comma B are the inputs from Q2. And for every state there should be some transition. So A comma B. Now check whether it is satisfying DFA. Yes, it is satisfying my DFA. So this is for the length of the string less than or equal to 2. Next. So design DFA for the language L which accepts all the strings over alphabet sigma equal to A comma B where length of the string is even. So I am going to read the strings of length even. So what are even? Which are divisible by 2 or length of the strings are even. So let us construct a string length of even length. AA, BB, AB, BA, 4As, ABB, ABBA, so on. Yes, I can construct. Check whether the length of the string is even. Yes, the length of the strings are even. 2, 2, 2, 4, 4, 4. The length of the strings are even. So it should read the length of the string as even only. So let us construct a language. Let us construct the language. Q0, Q1. Q0, Q1. So what is the question? It should accept a string length even. Even is nothing but it should remainder is 0. So 0 is nothing but I am going to take these accepts remainder 0. These accepts remainder zeros. This is my starting state. Let me check whether how it is accepting. So the first length string is AA. So Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. So the string is accepted. Yes. Let me check AA. Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. The string is accepted. The next one is BB. So Q0 on A, Q0 on B, it is moving to Q1. Q1 on B, it is moving to Q0. Check whether the string is accepted. BB. Q0 on B, Q1, Q1 on B, Q0. This string is also accepted. So let me check for 4A's. 4A's. Q0, 4A's. Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. This string is also accepted. It is reaching my final state. So the string is accepted. For example, if I take 3 length string, let me check whether it is satisfying or not. So Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. Q0 on A, it is moving to Q1. So check, Q1 is my final state? No, it is not my final state. Q0 is my final state. So this string is not accepted. This string is not accepted. Any combinations A, B, B, A or continuity B, B or A, anything you can take. But the length of the string should be even is our concept. So here Q0 is my starting state. So in the last example we have seen one initial, as DFA accepts single initial state and multiple final states. See here Q0, Q1, Q2 are the multiple final states. We will have in DFA only one initial state and multiple final states, as we discussed when we have talked about the DFA definition. So this is about string is even. So the same way string is odd. How to construct string is odd? So string is odd is nothing but it should have length odd number 1, 3, 5, 7. Okay, so those all comes under odd. So A, what is the alphabet over A comma B? A, B, A, B, A, B, 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 A, B, A, B, A, so on. This type of language is nothing but infinite language. It accepts odd length string. Odd length string. So let us construct the diagram. Q0, Q0, next Q1, Q1, and here what I am having, this is my starting state, and what it is A, Q0 on A, it is reaching to Q1. So when I am having odd length, it accepts remainder 1. It nothing but odd length strings are nothing but remainder 1, which are not divisible by 2. When we discussed about even, Q0 is the remainder. So on A, it is reaching 1. So Q0, this string is accepted. Now next B length. B length is nothing but Q0 on B, it is moving to Q1. Next A. So Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. Q0 on A, it is moving to Q1. So nothing but check it here. Q0 on A, it is moving to Q1. Q1 on A, it is moving to Q0. Q0 on A, it is moving to Q1. So the string is accepted. The string is accepted. Same way this is also A, B, A, Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q0. Q0 on A, it is moving to Q1. So nothing but these strings are also accepted. So same way which we have constructed the 5 tuples, for these also we can construct. So this is the difference for even and odd. If we have even, the Q0 will be the final state. If it is odd, the Q1 will be the final state. Okay. So this is about the length and even and odd functions. Examples. Thank you.